This is S9G.3, cubic modeling minimum maximum axis intercepts. So basically we are practicing the S9G.1 calculator steps. So important that you watch this video first in order to understand minimums, maximums, zeros. So these instructions are to find the maximum. These instructions, the zeros mean the x-intercept. People were having the most trouble with finding the zeros. And okay, so this one was a little bit tricky because of it was hard to see where it intersected here. So we've got x squared minus 2x plus 8. Now be careful here. Notice this is a big minus. So the mistakes that people were making is this one here is for minus, this one here is for a negative sign. So if you're using the wrong one, then you're going to get an error and you're going to be like, oh, it's not working for me. So make sure you're using the correct minus symbol. Okay, and then the other equation is y equals x plus 6. Okay. So if I hit graph, okay, ooh, my graph, the axis is wrong. Oh, duh, I didn't read the instructions. For the standard window, press zoom 6. Oh my goodness. Zoom 6. Oh, look at that window. Oh my goodness. All right. Now, this looks like it kind of only intersects touching once, but it actually is touching twice. So what are the instructions for finding the intersection of two lines? Okay, you're going to follow these instructions here from the S9G.1 handout. So you're going to push second trace intersect, second trace, go down here to number 5, intersect, and then I'm going to move the arrow close to the one that I want to do and then hit enter 3 times, and then it's going to tell me the value. So I'm going to move the arrow like there. It's close to it. See, it's blinking there. Blink, blink, blink. First curve, I hit enter. Second curve, I hit enter. Guess, I hit enter, and now it tells me that intersection is 1, 7. Now let's find the other one, because we have to repeat the process on the GDC to find the other intersection. Okay, so what's the process? Second trace, go down 5 to intersect, enter. I'm going to move it over here, and I hit enter, 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 and now I get the other one, which is 2, 8. Okay, so I need to talk about this question E, because people had problems with this in all of my classes. E, some of you say. What does that mean? Why did he make that weird sound? Is he going crazy? Let's see. Let's change this. We've got 4x cubed plus 3. Okay, I've typed it in right. The next one is 2x minus 6. Okay, and then we can graph this. And some of you noticed, and I told you, that it only intersects once. So second trace, go down to intersect, enter 1. It's got my quadratic equation. I hit enter. Second curve, it's got the line. I hit enter. Guess, I hit enter. And 3, comma, what is this that I see? Oh, I'm just going to write 5.75 here. If you write 5.75 here, I'm going to put a sad face on your paper. No, maybe I won't do that. But this is 5.75 times, so the capital E is scientific notation. So what that means, this means 5.75 times 10 to the negative 7 power. That's what this means. Okay, and so if I was going to write this out, it would be 0.0000061, right? 575. So 1, 2, 3, 4, 5, 6, 7. We've moved the decimal place over here. And this is approximately equal to 0. So that's what you put there. The calculator was not smart enough to say that this is not 0. And it doesn't even look like 5.7. This looks like it's on the x-axis. So if you write 5.75, I'm not giving you any points. Okay. This one, the graph doesn't intersect. You might have gotten an error and cried. Well, it's because it doesn't intersect. Okay, so I'm just going to let you check your answers on the next ones here. You need to follow the instructions on the S9G.3 in order to do this. Now, this here, this is actually really simple. So if what this says, as x goes to infinity, that means as x goes this direction, as x goes to infinity, we notice that the y value is going up. So what that means is that y also goes to infinity because it's just going up and up and up. Okay? And then over here, oh, I just wrote my key. I bet that bled through. Oh, wait. No, it didn't. Okay. Woohoo! All right. So when I have x going to negative infinity, that means when x is going that direction, when x goes to negative infinity, that means we're going to that direction, you're going to notice that y is just going down. So we can say that y goes to negative infinity because it's going down. As I go to the left, it's going down. So that's what this means. It's actually pretty simple. And like, oh, you never taught this to me before. Oh, you're learning it now. Okay, so that is called behavior of the graph. Okay, you need to practice the S9G.1 steps. These are the answers. Okay. Same thing. Check your answers. Okay, last page. Check your answers. And it asks for the range because the graph doesn't go below negative 15.2.